The adjacent diagram shows a fixed pulley used by a boy to lift a load of 400 Newton through a vertical height of 5 meter in 10 seconds. The effort applied by the boy on the other end of the rope is 480 Newton. So the figure is somewhat like this. 480 is applied load here, effort applied, and the load which is picked up is only of 400. So there is a difference. First, A, what is the velocity ratio of the pulley? Okay, so velocity ratio has to do with the geometry. If you see how much the effort arm is moving and how much the load arm is moving, that ratio is called velocity ratio. So because it is a single rope here, see, so whatever the distance this guy will pull down, the same distance this load will cover. So the velocity ratio will be 1. Okay, let's go the B part. What is the mechanical advantage? Now see how much advantage he is able to take. Ideally, it should be 1. Velocity ratio is 1, so mechanical advantage should be 1. But because see that there's a difference, 480 Newton is effort and the load is 400 only. So if you want to calculate the mechanical advantage, the effort into MA is equal to load, or you must have learned this formula. MA is load by effort. So load here it is 480 and effort, sorry, load here is 400. So this is 400. But to pull up this, we have to apply more force than the load, right? 480. So the mechanical advantage will simplify to 5 by 6. So this is the mechanical advantage. Now they're asking in the next part to calculate the efficiency. So how we can calculate efficiency? There is a relation. Efficiency is mechanical advantage divided by velocity ratio. So 5 by 6 is our mechanical advantage, and velocity ratio we already calculated in first part is 1. So the efficiency will also become 5 by 6, or if we solve it, it will go by 8 then first, then it will go by 3, and it will get repeated. So the answer we will get is 0.83333 go on, or we can say 83%. So the machine is working as 83% efficiency. That is why if you see the effort which we are putting in is not giving the exact results. There is some loss that may be due to the friction here, right? Maybe here the friction. So there are energy dissipation here. This is not a perfect system. This is a practical pulley. Okay, let's go ahead. Now, in the next part, they ask what is the power input developed by the boy. Okay, so what he is giving in. So what he is giving in is 480 Newton. He's applying force, and we know also the distance. So the distance is given. See, the distance is given 5 meter, and the distance is also it will come down. It will force is also downwards, and the displacement will be also be downward direction. So we can use the formula of work done FD cos theta, and the time also is given. It happened in 10 seconds, so we can calculate the power input, how much power we are giving in, so that we'll be able to calculate as 240 joules. Now what will be the power output, or what is happening here? They are asking us to calculate the work done on the load or work output. So first we can calculate the power output, that is work done by load. Because the velocity ratio is 1, if this is going 5 meters down, this has to go up 5 meters. So distance moved by this load is will be also of 5 meters. So 400 into 5. So again, we are using the same formula, FD cos theta. See, the load is here, and the tension is also here. So that's why FD cos theta. And then we'll apply it as, and we will get 200 joules per second, or 200 watts. So joule seconds can be written as watts also. So that is what we can say about this. Now see, the power output is lesser. If you see 200 and we were giving in 240, so there was a loss, right? So now they are asking like how much work was done on this, how much work. So we know the power now, 200 watts or 200 joules per second. So in 10 seconds, in the question they have mentioned 10 seconds, right? So in 10 seconds, the total work done will be 200 into 10, that is 2000 joules. So that will be the answer of power and the part E. Now let's see what they are asking in this one, that why we are um, the boy has to apply an effort which is greater than the load is lifting. Okay, yeah, because this is not 100% efficient machine we are having here. What is the justification for using the pulley then? The justification of pulley is that you can conveniently apply force. Now imagine this person, if he's pulling this weight, he has to put hands here and pull it upwards, which will be very inconvenient. If you see, if you want to pull anything, if there is a well and you want to, get water out of it, so if you just go here, that will be very dangerous also. If you want to pull this up directly like this, it will be not convenient. But if you have a pulley, so we can have a rope and you can comfortably pull it without, being inconvenient, or you can do work easily. So the pulley is used to change the direction of force. You can conveniently pull. And even if you see this guy, he can just hang on this. He can use his own weight to pull the force. So how convenient it is, which was not possible when we were pulling like this. So this can be justification of why we are using pulley. Okay, let's go next. The diagram below shows the combination of a movable pulley P1 with a fixed pulley P2. So this is the fixed one and this is the movable. So it can move up and down. Okay, we are lifting this weight. This is given W. Now let's see what is state the function of fixed pulley P2. So what the fixed pulleys are used for, they are used to change the direction. So we don't have to, if this pulley is not there, we have to pull it like this upwards again. So if we introduce this pulley, what will happen? Like, can pull it now downwards at our convenience as we were pulling in the previous case. Okay, so the part A is done. If the free end of the string moves through a distance x, by what distance the load W is raised? See, it is the case of movable pulley. This is just changing the direction of force. So the mechanical advantage what we get is of 2. So that we should know. So the mechanical advantage we will get 2. And if we are thinking this is uh, ideal scenario. So mechanical advantage will be 2 and VR also will be 2. Now velocity ratio 2 means that you have to pull two times distance here to pull 1 meter here. If this is going 1 meter up, then you have to pull 2 meter. Right? It is going only 1 meter up. But for that, you need to pull by 2 meters. So that is what this intuition from velocity ratio is. So the movable pulley, single movable pulley has the velocity ratio of 2. So if we are uh, moving the distance x, if we are moving this distance x, let's say 2 meter, then what we are doing, we just halving it. We need to take a half of it. So if this is move distance is x, what will happen to the distance moved up? It will be just x by 2, right? So that will be the answer for the B option. Okay, so it will be x by 2. Let's go to the third option now. So what effort has to be applied at C? This is the point C. In order to just rate the load of 20 kgf, we need to neglect the weight of the pulley P1. We have to neglect the weight, otherwise we will end up pulling this also up, and we have to factor that in. And also there is no friction. So ideal scenario. In ideal scenario, the mechanical advantage will be exactly equal to the velocity ratio. So think about mechanical advantage as if it is 2 times, what does that mean? It means you just need to put effort half. So if you want to pull up this much, 20 kgf, just half of the force if you'll give it here, it will be raised. So we just need to pull 1 by 2 times of 20 kgf, that is 10 kg effort we need to put to pull up this much of load. Also, here is to visualize the difference between the distances. Here I have made like this point is there. So this is where we are putting effort, and here is a pulley. So I've just made this size smaller, and you can use this horizontal line for reference. So if we are putting this point, let's say here, okay, let's say here. So this will become like this. So this is the distance we have moved, which I've shown in blue. So what will happen? How much this will go up? This will only move up half of this distance. Why it is moving? Because see, it has two wires. If this pulley is going up, if this pulley is going up from here, it is releasing the strings or strands from two ends. So one will go from here and one will go from here. That's why it will go up. So that is why it moves up with the less distance. So if you see, if you compare, if this has moved x, it has moved up x by 2. And this will happen in the case of movable pulley. Okay, so see, we already have discussed. Let's go to the next question. Yeah. So a pulley system with a velocity ratio of 4 is used to lift a load of this much through a vertical height of 20 meter. Okay. The effort required is given, and in the downward direction, calculate the distance moved by the effort. So the velocity ratio is given, then let's do step by step. First, let's calculate the distance moved by the effort. We know velocity ratio is effort distance divided by load distance, and that is given as 4, right? So distance moved by load is 20 meter. Intuitively, you can think if this is 4, it means you have to put 4 times more distance at the effort, right, to put a load. So if load is moving 20 meter, we have to go 4 times more at the effort point. So the from this formula also you can get this, like the distance moved by effort will be VR, velocity ratio, into 20, which will be 80 meter. But intuitively also we can do, but we need to understand what if this value 4 tells. 4 tells you have to move 4 times. The effort point has to move 1, 2, 3, 4 times. Here I'm taking 1, 2, 3, 4 as this one. If you want to move one distance up the load. So that is the uh, velocity ratio communicating. So intuitively we can answer, okay, the load has moved, let's say this is, let's say this is 21, 20. So this will be what? This will be 4 multiplied by 20. So we have to move 4 times. So this is the velocity ratio we are talking about. Now they are asking what is the work done by effort. Just multiply FD cos theta, ignore cos theta because it will be 0 degree. So just multiplication of force and displacement. Force will be 50 into 10 because G is 10, and then we have to multiply it by 80 because see, they are asking about the work done by effort. So effort has moved 80 meters. So we have to take that distance and plug it in while calculating. So this should be 80. Now we'll calculate work done by effort is 40,000 joules or 40 kilojoules. Okay, let's go next. Now they have asked to calculate the mechanical advantage. So mechanical advantage is how much load you have able to pick with the effort. Okay, so load will be in the numerator, remember that in case of mechanical advantage. So we were able to pick 150. We put in numerator and 50 was the effort. So we are creating mechanical advantage of 3. Okay, 3 times. So we are able to pull up things which are 3 times to us. So we just have to provide 1/3 of the total weight which you want to pull. So understand these values intuitively, then these questions becomes very fun. Okay. Then what is the efficiency? Efficiency, we have a formula which have a relation eta is equal to MA by divided by VR. We have calculated MA already here 3. We can put it VR was 4. So VR comes from geometry. So it was like ideally, right? Ideal design. So it will be 3 by 4.75, or it will be the machine is 75% efficient. How many pulleys are required? If we are imagining this as a block tackle system, then we need to have 4 pulleys, because in block and tackle system generally 4 pulleys give 4 supporting strands to the load. So here it is a load, for example. So in case of block and tackle system, you will see eventually there'll be 4 strands which will be supporting this. 1, 2, 3, 4. So that is why 4 pulleys does that in block tackle system. That's why it is given, like we can tell that the number of pulleys will be 4. Now let's see the last example. A block and tackle has 2 pulleys in each block, with the tackle tied to the hook of the lower block so as to apply the effort downwards. Draw a neat diagram to show this arrangement and calculate the mechanical advantage. B. If the load moves up by distance x, by what distance will the free end of the string move up? The string has to move up. The free end has to move up. Now, first thing is there is a confusion of creating a diagram, but remember we have to take a hint what they want. So they want, first thing is there are 2 pulleys in each block. We are clear. We will draw them first, and then we'll put the tackle or this rope. And how to do that? Let's do that first and come back to the solution of it. So let's see. So what is the change here? I will use green color for the tackle. So how this has been made, let's try that, making that. Okay. So I have to put pull the string upwards. So the free end of the string move up. So that is the main point here. Okay. I will also show when we have to do it, pull it down, then what is the difference in both of them. So let's say I have to pull it like this. Okay. I'm pulling like this. So this is my effort. Okay. Let me make little longer. Let me say I am pulling like this. Okay, this is my effort. Okay, now you have to tie this rope outside and then inside. So that is a hint. Always go wrap this around, wrap this around, and then go to the other block and tie it from outside. We are gone here. Okay, now don't go directly here. So that will be outside to inside. No, first complete the outer circle, go to the second block. Okay, come like this, then go to this block, and then finally tie to this fixed end. Okay, so this fully. So this is what is called one block. So this will be one block, and this will be one block. Okay, so this is the fixed block. This is a movable block. This can move, and this is fixed. So this is what they are talking about. So we should know the terminology: fixed block, movable block, and how they are. But most important is they will, in exams also they ask to tie this rope, show the how we are pulling the load. Now the number of strands, if you see, supporting this load are how much? Let's count them. So see, there is one here, one here, one here, 3. Okay, now 4. But because of we also pulling it upwards, we are also supporting the load. So the fifth one becomes this. So in this case, the velocity ratio becomes not 4. We are using 4 pulleys, but that formula is when we are pulling downwards. I will show you it here. But in this case, the velocity ratio will be 5, because it depends on the arrangement, how we are pulling, etc. Now let's do for this one, but I will not apply this upwards. I will apply it downwards. Let me use a different color. Okay, so now let's see if I apply effort like this. Again, we have to tie the rope. We will do the same thing. We'll go block by block. First block to another block outside, then go to the previous block outside, and then wrap it up and then finish it up. here. So this is how you will, by practice, you will be able to get. Otherwise, in exams, you can be confused where to put ropes to. So this tackle is, dealt like that. Now think about how much this load is getting supported with how many strings. So if you see, one is upwards here, one is upwards here, two, three, 4. In this case, our effort is not supporting the load. That is why in this case, VR is equal to 4. This is a major confusion. So that's why I thought it will be better if we clear it right here. If we are putting it upwards, we are also supporting the load. So the velocity ratio will be more. Now let's get back to the solution. So this is how diagram finally can be made. They have shown it by T. So whatever the effort we are putting, that will become T. T is the tension in the rope, and if there is one rope, tension will be same everywhere. So instead of E, we they have shown it T. So not a problem. We can understand that. Now let's clear. First, they ask us to draw a neat diagram. You have drawn a diagram. Then B, if the load moves up the distance X, by what distance will the free end of the string move up? So we should know by this that 5 strings are supporting it. One, two, see, one, two, 3, 4, 5. So the velocity ratio is 5. Velocity ratio is 5. So what does that mean? That the effort has to move 5 times. So if the load moves x, the the effort will move 5x. So that is how we can calculate. And there is also, if they want a relation between the tension in the rope and the load, we can say the downward force is load. This downward force is load. And what is the upward force? It is, you can say 5E if effort is same as T. Remember that, okay? So this is not different. E is equal to tension. So we can say 5E or 5T. So 5T upward force is there. So it means if they are in balance, then L has to go to 5T. So there is a relation between tension and the load also. Now the explanation, the distance moved will be 5 times as the work input has to be equal to the work output, assuming it is an ideal machine. Thank you. That's it.